Codestral is the new large language model that's specifically tuned for software engineering purposes, being able to complete a majority of the benchmarks compared to all the other large language models that are tuned for coding. And guess what? It even does better than models that have 3 times more parameters, including Codelama 70 billion, and comparing that with other 70 billion parameter models. Codestral is only at a 22 billion parameter size. So it means that it's been specifically tuned for around, it says, over 80 plus languages, and has done a very good job on all of the benchmarks that you would typically benchmark a model when compared for coding exercises. And what we want to do is just take a quick peek here to see what that looks like. Okay, so it was just released just today by the Mistral team, and the idea was they made a model fluent in 80 languages, including the popular ones: Python, Java, C++, JavaScript, and Bash. I don't know. Well, I guess, yeah. Okay, so shell scripting, sure. That is a common case. Oh, it's got some Swift and Fortran in there. Here's the deal. If Codestral can save time for developers and effort by completing coding functions, writing tests, and completing any partial code, filling in the middle mechanisms, Codestral is going to help a lot accelerating software engineering. That's actually pretty big. And what's great is it's only 22 billion parameters. So that means it can run on a lot of common existing hardware that you might already have at your house today. Now let's take a look at the benchmarks. Might be a little tricky to see, but if you look, it does have the largest context window, and it outperforms mostly, primarily compared to all the others here. So we see the human eval, MBPP, and a couple others. It outperforms. Now, compared to this MBPP on DeepSeek Coder, 33 billion parameter, it's only just a few percentages difference. Though that is, a few percentages is a big deal. However, we still see that Codestral being at at 22 billion parameters and offering a larger context window, we are seeing that it's still better in this case, right? I'd call it better. If we take a look at the individual languages here, human eval, Python, C++, Bash, Java, PHP, TypeScript, C#, we see that it comes out on the top for Python, by far ahead of the curve, roughly similar across the board for C++. It wins in Bash at 42%, though Bash is pretty... There's a lot of symbols involved in Bash, so you can get pretty crazy. Java is number 1, PHP is number 1. TypeScript, it came down, it's still pretty high compared to Codelama 70 billion and CodeSeeker, though Codelama, or Llama 3, 70 billion, it comes in at 74%, which is quite a bit higher. And then C#, kind of all around the same realm. Human eval is at the top. Oh wow, look at this. Okay, so this one's interesting. The human eval FIM, fill in the middle, right? So this is going to take some code on either side, and it needs to make the code work, right? Complete the code. Wow, that is impressive. These are all approaching 90 or in the 90s in terms of its completion. That's huge. Now, wow. So that's the vast majority of all coding tasks in general will be mostly fill in the middle code work, because once the code's already written, the life of that code needs to extend further into the future, and that usually takes the majority of the work. So that's kind of impressive. So you can try out Codestral immediately by going to LeChat, which is a web form where you can just interact with it, sort of like ChatGPT. You can also get it to work in your VS Code and JetBrains IDE editor in integrated development environments. Human eval is a benchmark that we use for large language models to see how good one of these chat models can be with coding exercises. Specifically, there are a lot of benchmarks that test how good is a large language model performing in the various tasks that we have it. Coding is one of those, right? Software engineering, programming, where we write code. Human eval is specifically targeted for that purpose. And I was very curious. I had 2 questions. What does one of these problems look like? How is it evaluated for success? And then what would a normal human be compared to these other models, right? So we've got these AI models that are doing human-related tasks, but if you pin a human against it, how well would they perform side by side? First, let's take a look. Here is one of the examples. So here is a code problem. It says, given an empty list of integers, return sum of all of the odd elements in the even positions. Oh, that's kind of tricky. Okay, that's a tricky one. And so what it would do, it gives you some examples, which is nice. And then the highlighted section here is where the AI or the human has to fill in the algorithm, right? They have to write that algorithm that completes the given problem. And so the AI or the human would write this code. That function would then be executed, and then the output would be compared to see if it got the right answer. So if we were to consider a human running this exercise, or we test a real life software engineer, the average software engineer, you have sort of a few things to consider. The third item might surprise you. So if we start here, there's 3 items here. Really, we care about the experience level. How many years, has that software engineer been working? Now, if you compare that with like an AI, these AIs, they are trained, they could be within several weeks, but a human, they need years or even decades to be able to obtain this level of deep understanding of programming concepts and problem solving strategies, versus an AI can be trained in a matter of weeks. Now that's a big difference when you compare the two. Also, familiarity of the problem based on your industry. What are you going to see, and sort of what environments have you exercised those? So that is also a human aspect to this. And often AIs don't have that data, right? They're not going to have those real world experiences. So there is a human advantage in this case. The third item I was really interested to see is the time constraint, at least in terms of a human being able to effectively complete these problems. Now, a human could, do trial and error, or if this was just a pencil test, in that case it kind of is a pencil test where you do have to write in to make it fair as a comparison, right? Because the AI is only writing it out, and so a human would have to follow suit because that's all that's possible. You would see that the time constraint, a human would take a lot longer to complete the task, like hours versus minutes, and the human would get tired comparatively, right? And so you've got this AI that is able to just crunch through all this data, just basically, and barrel through and perform at an army's level of humans. Given all these factors, we do see that between 70 and 90% of the eval would be completed by a human, even if the human had more time to do it. Which is interesting, because what we're seeing, these benchmarks, these AIs, based on which eval is being benchmarked, are already performing at near human level, which is really fascinating, right? It's really interesting. That means that we're very close to getting an AI that is just at that full human level. You're still going to need to be able to direct where this AI is going to go, because it doesn't have any ambitions or understandings or desires. So we still need that software engineer there to figure out where to direct something like this. Meanwhile, right, in this time, I see an increase in job demand for software engineering in the future here in the coming years. We see that now that software engineering is becoming more accessible and it's become more of a streamlined capability within the industry, more businesses are going to be adopting software engineering practices. You can write software more quickly and provide the ability to sort of reduce the overhead of ownership of code to a point where more businesses will want to have in-house software engineers, which means that we're going to see an increase in demand for software engineering across a wide range of businesses and industries. Codestral, which is Mistral's AI first ever code model designed for code generation tasks, is only 22 billion parameters. This model is available to us on Codelama.com as a model that we can use and download and run locally on our system. Being that it's a 22 billion parameter model, it is a 12 gigabyte download, so pretty heavy, but not too heavy compared to some of those much larger models. I'm downloading it right now. I'm almost done. Oh my god, it's 100% done. And let's see how it works. Let's see how it performs. So of course, once you've downloaded Codelama, all you have to do is run Codelama poll Codestral, and this Codestral model will be downloaded on your system. Next, you can execute Codelama run Codestral, and then type in your prompt a Python function that adds two numbers together. Let's just do something very simple. Let's see is it gonna work? I don't know. We'll find out. It did it. It totally works. It did exactly what I was hoping it would do, we see that it answers back with the exact code that I'm looking for, and it provided an example even. And I was watching the output, and it was in my head, I was like 5 plus 3. Oh, that equals 7. Of course, it equals 8. I don't know why I wasn't doing the math right, but the AI did get it correct, and it had a very concise output, which is really satisfying. Usually the models will have more of a verbose output, which generally helps guide the model and its output to be more accurate. The cool thing that's different with Codestral is that it seems a lot more concise, like significantly so, right? So one sentence here for the intro, and then another for the example, which is amazing. So we cannot even say that this performs significantly better than most of the other models. That's just very much satisfying. And it's only 22 billion parameters.